Biomechanical Principles by ENT 14004493. So this is the content page and it's all the subjects I'll be talking about. So starting with anatomical principles, so the types of muscle contractions is isometric, isokinetic and isotonic. So isometric is the constant length contraction, meaning a muscle contraction where a muscle has no appreciable change in its length. So an example would be skiing, because skiing you need static strength, which is required to stabilize your upper and your lower body. So moving on to isokinetic is a contraction where the muscle shortens or lengthens at constant speed. And an example for this, quite hard to find, but it is breaststroke in swimming. That is a good example because water provides a constant and even resistance to the movement of adduction, and that basically means which is a movement that is made towards the middle of the body. So this is what maintains the stroke at a constant speed. And moving on to isotonic is where the muscle contracts against a constant load. So my example for this is a squat. So there's two phases to the squat. So the downward phase where the quadricep muscles will contract eccentrically, which means that they lengthen, and the upward phase, the quadricep muscles contract concentrically, which means that they shorten during that movement. So exercises like squats doesn't just use one muscle, it uses multiple joints and muscles, and so it's done mostly eccentrically as the muscles lengthen to provide a braking mechanism that slows the rate of movement and protects the body against any type of injuries. So looking at antagonistic pairs, starting with agonist, so the muscle that shortens to move a joint, so they're also considered the prime mover, and it also controls the movement of the action through contracting. And then going down to antagonist is a muscle that relaxes in opposition to the agonist, and this returns a joint to its natural position and relaxes and lengthens. But if it didn't do that, the movement will not be able to happen. Then the synergist, which are muscles that enable the agonist to operate more effectively. They work with the agonist to control and direct movement, but modify or altering direction of pull to the best position. So when performing a certain sporting movement, you not only have a major muscle conducting the movement, you also have a smaller muscles assisting the muscles around and in the joint, helping with the movement you're making. So these are what the synergist muscles are. And then there's also the fixator. So the fixator muscles stop any unwanted movement by fixing or stabilizing the joint or joints involved. The fixator muscles stabilize the origin so that the agonist can achieve maximum and effective contraction. So they basically stabilize the joint during the desired movement, and it basically just holds you in place. So moving on to the reciprocal inhibition. This is the process of muscles on one side of a joint relaxing, which is the antagonist, to accommodate contraction of the agonist muscle on the other side of the joint. So the joints are controlled by the two opposite muscles, the flexors and the extensors, which they work together at the same time to create a smooth movement. So now looking at kinematics. Kinematics is a description of movement without referring to the forces involved. There's two types of kinematics, and the first being linear motion. So linear motion is a movement in which parts of a system move in the same direction at the same speed or acceleration. And then it's split into further two types, which is a rectilinear translation and curvilinear translation. So rectilinear is basically motion along a straight line or path. An example would be a 100-meter sprint, because you obviously run in a straight line. And then the curvilinear is a motion that occurs along a curved line or path, and that would be, in comparison, would be a 200-meter bend, because obviously you're running in a curve at the beginning. And then the other one being angular motion. And it's where all points on a body moves in circles around the same fixed axis. The axis can either occur inside or outside of the body. So if we move on to vector quantities and scalar quantity. So a vector quantity is a physical quantity that has both size and direction, and scalar quantity is a physical quantity that has only size. So vector quantities looks at displacement, velocity, acceleration, deceleration, weight, and momentum, whereas scalar quantities look at distance, speed, mass, and inertia. So these are the two working out triangles basically. So we work out how to work out displacement, velocity, or time, or distance, speed, or time. So an example would be of a scalar quantity would be, for example, what a time a hockey player had been travelling for if they ran at 1.64 meters per second minus 1 for 20 meters. So you do d divided by s, which is 20, divided by 1.64, which then equals 12.19. So you basically just cover the letter that you want to find out And for example, if I cover velocity, you do displacement divided by time, or if I cover displacement, you do velocity times time. So moving on to acceleration, which links to that, is the distance an object or an athlete has travelled in a given direction. So to work that one out, you have to do final velocity minus starting velocity. So you work that out first, and then you put that on top of that that equation, then you divide that by the time, and that is what gives you the acceleration overall, and it's measured in meters per second minus 2. We're looking at angular kinematics now. It is the same, apart from that you add the word angular to in front of the scale and vector quantities. For example, angular acceleration, angular speed, angular displacement, etc. So it goes on. We measure angular kinematics in radians, which is rads. 1 rad is equal to 57.3 degrees. So there's 360 degrees in a circle, so 360 equals 6.28. So angular distance and displacement will be expressed in rad. So to convert degrees to radius, you have to first divide by pi. You have to divide pi by 180, which is 0.02, and then you times it by the degrees. An example would be, like during a bowls match, the bowler's bowling arm travels at an angular displacement of 85 degrees in 6.2 seconds. Then what is the angular velocity of the arm? So the answer would be 3.14 divided by 180, which equals to 0.2 times 85, which the answer gives 1.48. And then you divide that answer by 6.2, which gives you 0.24 rads to the second of minus 1. And then moving on to kinetics. So kinetics is an assessment of movement, especially referring to the forces influencing it. So the different types of so the difference is that kinematics doesn't consider force, it only concerns with the description of motions, and whereas kinetics considers the force as well as the movement. So you consider forces like common forces such as human movement, gravity, air resistance, friction, reaction forces exerted by the ground. An example could be like Mo Farah. So when he trains in Kenya, he trains at a high altitude, and that is a necessity for him because that increases the body's ability to carry oxygen, which makes him quicker when he runs. And then, so if we move on from that, looking at the Newton's law of motion, there are three. There are three different ones. So the first law, the second law, and the third law. The first law, looking at a body will remain at rest or at a constant velocity unless compelled to change by external force acting on it. The second law, the acceleration of a body is proportional to the force causing the acceleration, and the acceleration takes place in the direction that the force acts. Or the third law, for every action there is an equal and opposite reaction. When any object exerts a force on another, then it experiences an equal force exerted by the other, but in the opposite direction. An example would be, for example, if you have two American football players, they approach each other just before the impact. So the red player moves with a velocity of 6 meters per second minus 1 and a mass of 90 kilograms. Then the second player moves with a velocity of 7 meters per second minus 1 and a mass of 80. So what is the momentum of each player? So here we're looking at the second triangle, which to work out the momentum you times mass by velocity. So if I times mass by velocity of each player, so I do 90 times 6 for the first one, which gives me 540, and mass times velocity for the second one, which is 80 times 7, and it gives me 560. So if I want to know the total momentum of the collision, it would be 540 plus 560, which gives me 1,100 kilograms per second. So if we now look at angular kinetics, so torque is included in that, which is rotation but to be initiated by torque, and it results from a force acting at a distance from the axis of rotation. So torque's worked out by timing force and distance. So if we look at this example, so what is the torque if a force of 8 newtons is produced 25 centimeters away? So you do force times distance, which is 8 times 25, which gives you 200 Newton meters. Sorry. And then talking about the muscles and torques, they can be used to create an internal torque, which allows movement around a joint. And for example, during a bicep curl, the biceps create the movement, and so there is an internal torque. And then the internal torque can be increased through appropriate weight or resistance training, which then increases the muscle generating capacity. So it's always improving. So if now we move on to force couples and transfer of momentum, looking at the figure skater, they're just there. So force couples, so if the same force is applied in both directions, the net force is going to be 0. So the larger the couple, the greater the angular acceleration. Therefore, the speed will also be quicker, just like that figure skater. So if we link it to transfer of momentum, it could be transferred one object to another, and also from one point of the body to another. So an example would be this figure skater. So a figure skater starts a spin by pulling in his arms to lessen his movement of inertia. By the conversion of momentum principles, the angular speed must then increase. To come out of the spin, a skater simply extends her arm to increase angular momentum and decreases angular velocity. These are my references. So this is the first page, the second page, and the third. And that is it. Thank you for watching, and I hope it has been very informative.